Control circuits in multi. First, Panto control circuit. Normally in single loco, whenever you are keeping the HP on one position, if your additional CCBA and CCPT are in good condition, let us assume you are in cab 1 and you operated the ZPT1, cab 1 ZPT1 on one position. Through one interlock, the supply will come like this to VEPT2. Whenever VEPT2 coil gets the supply, it will admit the pneumatic pressure into the servo motor. So your Panto 2 will rise. So if it is a multi, how the supply will go to the trailing loco? Let us we will see. In multi, so normal position of the BLSN is in up position. Whenever it is in normal position, through its BLSN 1 and 2 NC interlocks, supply will come up to like this. Come like this. In MU jumper cables are connected. MU jumper cables are connected. Through these jumper cables, the supply will go to the trailing loco. In trailing loco also, BLSN is in normal condition, so its interlocks are in closed condition. So the supply will come to the trailing loco VEPT2. Whenever trailing loco VEPT2 gets the supply, so it will allow the air pressure into the servo motor. So both Pantos will rise now. Whenever you are operating the BLSN switch in leading loco, so here BLSN switches are provided. So if you operated this BLSN switch, this interlocks gets open circuited. Whenever this interlock gets opened, VEPT2 of trailing loco gets open circuited. So whenever VEPT2 gets open circuited, VEPT2 electrovalve de-energizes, thus air will exhaust at VEPT2, so that your trailing loco Panto will lower. So again, if you raise the BLS, if you operate the BLSN, so it's normal position, up position. If you keep the BLSN in up position, the supply will again go like this to trailing loco VEPT2, and again your VEPT2 will rise. So here one important point is, please observe, if CCPT of trailing loco regarding Panto control circuit. So here CCPT of trailing loco is completely out of the path. So it means that whenever trailing loco CCPT is melted regarding Panto control circuit, there will not be any indication. So whenever CCPT is melting in trailing loco DJ trips, but Panto will not lower. For VEPT2, the supply will come from the leading loco itself. So what will happen if leading loco CCPT melts? If leading loco CCPT melts, so the supply for VEPT2 of leading loco and trailing loco will get open circuited. So it means whenever leading loco CCPT is melting, then both locos Pantos will lower along with the tripping of DJ. It is a simple Panto control circuit for MU locos. DJ control circuit. So in DJ control circuit, these are the branches. Whatever the interlocks provided on these branches are removed. For your simple understanding, only the branches are shown here. So here in DJ control circuit, relay Q118 branch is there. Next, relay Q45 branch is there. Q44 branch is there. C118, EFDJ, MTDJ are available. Let us assume it is a leading loco. In leading loco, here jumper cables are connected to these branches. It means that one jumper cable is getting supply Q45 branch and another one on common branch of MTDJ. Similarly, in trailing loco, same. Whenever you are connecting the jumper cables, the connections will be like this. It means that on Q45 branch, blue color line is going to trailing loco Q45. Similarly, on MTDJ common branch, so a red color path is shown for the trailing loco. Here BLSN switches are provided. Normally when they are in up condition, they are in interlocks are in closed condition. When you operate the BLSN, that is when you keep it in down condition, then these interlocks will open. Whenever you are keeping HB on one position, your Q118 will energize in DJ control circuit. Next, after creating the pressure, ZPT will close here, raising the Panto. If CCDJ and BP1 are in normal condition, after closing BLDJ, supply will come up to BLRDJ. If you press the BLRDJ, the supply will come to Q45 if GR is on 0. Now the same supply will go through the jumper cable. In trailing loco, whenever you are keeping the HB on one position, trailing loco Q118 is energizing. Along with the leading loco Q45, trailing loco Q45 is also energizing. Whenever you are closing the BLRDJ, so the supply to Q45 is goes through the jumper cables to the rear loco Q45 branch. That is, along with the leading loco Q45, trailing loco Q45 is also energizing. Whenever trailing loco Q45 is energized, so in leading loco and trailing loco, Q44 relay energizes independently. So whenever Q44 branch energizing, its interlock gets closed on MTDJ common path, so that the supply will come to the C118, EFDJ and MTDJ. It means that in leading loco, MTDJ is getting the supply. At the same time, if your BLSN is in normal condition, up condition, the same supply will rush to the trailing loco like this. It means that in DJ control circuit, when compared to single unit, here Q118 branch and Q44 branch are operating independently. They are energizing on their own loco controlling fuses. But whereas if you see the Q45 and if you see the common path of C118 EFDJ MTDJ are getting the supply from leading loco. Whenever you are pressing the BLRDJ, Q45 of trailing loco is energizing the same time when the leading loco Q45 is getting the supply. At the same time, trailing loco 45 will energize and 45's envoy interlock will close on trailing loco Q44. Whenever interlock is closing on Q44 branch, Q44 will energize through trailing loco battery supply. Whenever Q44 of trailing loco is energizing, its envoy interlock closes on the common path of C118 EFDJ and MTDJ. It means from leading loco, the supply is coming through BLSN from leading loco to trailing loco BLSN, and supply comes up to the Q44 NO and waits at there. Whenever Q44 relay energizes, its NO interlock closes on common path of C118 EFDJ MTDJ and they gets the supply. This is the DJ control circuit. This is the DJ control circuit. In this DJ control circuit, if you closely observe the trailing loco condition, if you clearly observe the trailing loco condition, in trailing loco, CCDJ and BP1 DJ are CCDJ and BP1 DJ are open circuited. It means that in trailing loco, if CCDJ is melted, there will not be any action. Similarly, in trailing loco, if you press the BP1 DJ, there will not be any action. There will not be any action. If Q108 is not energized, then this particular loco DJ will trip. Similarly, if any branch, that is Q44 branch or MTDJ branch, gets open circuited, then automatically that particular loco trips. For example, if you take the CCPT fuse here, CCPT fuse, we already discussed the trailing loco CCPT condition in Panto control circuit. Here, whenever CCPT fuse melts, so Q108 will not energize. Similarly, the same supply will go to the Q44. It means Q44 will also not energize. It means whenever trailing loco CCPT melts, so your DJ trips, but trailing loco Panto will not lower. Then what about the CCPT of the leading loco? If CCPT melts, leading loco MTDJ Q44, leading loco Q108 gets de-energized. Along with this, the supply which is going to the trailing loco, will also gets open circuited. It means that whenever a CCPT melts, so leading loco MTDJ de-energizes and also trailing loco MTDJ also de-energizes. Similarly, if leading loco CCDJ melts, leading loco MTDJ gets de-energized and trailing loco MTDJ also gets de-energized. It means both locos DJ will trip. Whereas in trailing loco, if CCDJ melts, there will not be any action. But when you change the cab, that is from leading loco to trailing loco, when you change the cab, then you will experience the ICDJ. Similarly, when you operated the BP1 DJ, the supply to MTDJ end of leading loco and the trailing loco gets open circuited. Both locos DJ trips. This is all about the DJ control circuit in multi.